Okay, what's the initial height? Starting height's 180. And do you happen to know, is it 180 feet or meters? Has to be meters because this formula is in meters right there. Okay, next one, the initial velocity, 5.6. And just so you know, that alone wouldn't be good enough. 5.6 what? MPS. Because the units totally matter. I mean, what if that's miles per second? I mean, we'd have to know it's meters per second. And what is the y-intercept? The y-intercept? It's kind of a trick question. The y-intercept is where x equals 0. There's no x in the equation, but that's like x. So if you make those 0, this will cancel out, and it's 180 again. And if you're going to use units, it would be in meters. Any questions on those three? All right, I'd like you to make an equation for me then. Instead of having the info given to you and you say, what's what? Make me an equation for this. And I'll have you check with the person I pair you with in a moment. Actually, let's get the groups figured out right now. So here we go. I want you to write me an equation, and you check with the person next to you if yours is the same as theirs. Write me an equation for this situation. A person is standing on the ground, and now actually let's make them standing on something that's off the ground. Okay, they're standing on a table. So imagine for a moment I'm standing on this table. Okay, and then this table is 3 feet off the ground. Okay, and from there I am going to take the hat which is on my head, and I'm about 6 feet tall, and I'm going to take it from my head, which is obviously 6 feet off of my feet, right? And then I'm going to throw it up in the air and let it gently arc down to the ground. Now imagine for a moment that there was no wind resistance, so we're taking the center of gravity on the hat, and so therefore it's just like throwing a ball, okay, but it's my hat, all right? So I'm going to toss my hat into the air and let it drop to the ground. So that obviously added a little bit of complication of where it is. What else do you need to know to write the equation? How hard do I throw it? No, I don't have to tell you that. How hard do I throw it? Yes, I do have to tell you that. And that's going to be at 2 meters per second. Yes?
You have to convert the 9 into meters.
It's a good question. Let's make it in meters instead. I'm about 2 meters tall, and my table is about 1 meter tall. So let's go with all meters. Good point. Check with the kid next to you, see if you got the same thing. If you don't, explain why, what your reasoning is. Okay. I strongly recommend you get used to this in math, that a picture is worth 1,000 words. If you can make a little sketch of it, it makes a huge difference. This works on the ACT test as well. So you don't have to make a complicated drawing, but if here's the ground, and here's the table, and it's up 1 meter, right? And here's me standing on the table, and I am another, how many meters? 2 meters. Then the hat, which is on top of my head, is starting at a total starting height of 3 meters. So hopefully you had that in your equation. Negative 4.9 x squared. I said I was going to throw it at 2 meters per second, right? So 2x plus 3. Raise your hand if you had that right. Okay, good. Now I'd like you to tell me, where would the hat be height-wise, like off the ground, at time half of a second? That time is 0.5 seconds. I'll pause while you crank that one out. Okay, so here's mine. I'd like you to walk me through. Tell me what to do to find it at a half a second. Second, trace, which makes me go to calculate menu, okay? Value is correct. It's blinking on the x. What is x, by the way? Is x like the amount of jello that is involved in the problem? No, what is x? Time. So its time is 0.5, okay? And then it says 0.5 is 2.775. Raise your hand if you had that one right. Okay, good. What did we just find? Number of chickens in Bolivia? How high it was in meters at 0.5 seconds. Okay, good. Next thing, I'd like to find out how high did the hat go? What was the highest it ever went? If you don't know this process, ask the person next to you. How high did the hat go? Total, max. While you're doing that, I'm going to do a quick zoom box because I don't like that my graph is kind of hard to see. So I'm going to box in. If you don't know how to zoom a zoom box, you might want to watch me do it. You choose zoom box, and then you get the dot strategically positioned so you can hit enter to start your box, and then you slowly drag your box over the area you care about. And it helps you zoom in because I really don't care about anything except this area right there. And now it'll make my graph a little more focused on the area that I care about. That's called a zoom box. All right. Maddie, what did you say? Well, first of all, walk me through it. Second, trace, which puts me in the calculate menu. Maximum. All right, I'll go 4. Left bound, what does that mean?
Go left.
Left of it. Good. Then right of it. And yeah, that's about it. Okay, and then guess exactly where it is. It's about there, but you hit enter to get the exact right answer, and it says 0.20. So is the height 0.20? No, but that's something important. What is it? The time when it hit that height. The time is 0.20 seconds. So that's only 0.2 of a second. That's really short, 0.2 of a second. After I threw my hat off, it reached its highest. And then after that, I can see the 3.2, and that means it was 3.2 meters up off the ground. It started at 3 meters, so it only went up a little ways. Because basically, I didn't throw it very hard. I was only throwing it at 2 meters per second here. Okay, good. Next question is, when did the hat hit the ground? Another way to ask that question would be, how long was the hat in the air? I'll pause for a second while I find that one. Okay. Let's go with, let's see, RA in the back corner. Tell me what to do. You don't know? All right. This test is tomorrow. You realize this, right? All right. Make sure you spend some quality time learning between now and then. All right. AS, tell me what to do. Second trace again. Now, which of those options is it to find that spot where it hits the ground? 0. Give me another name for it. Intercepts. X-intercepts. What else? Solutions. What else? Sets. All right. But this one chooses to use zeros. Okay, good. So we say 0. And now, tell me what to do. All right, and if I think that's the 0 spot, I'm heading for it right now. It's somewhere around there. I want to be left of it. Good. Now what? Okay, now I'm going to go right of it. So, oh, wait a minute. I hit enter already, so I'm good. Now I'm going to go right of it. Notice I don't even have to be on the screen. And then the last one is I have to get right on top of it. That's the 0 point, and I'm guessing where it is. It's about there. And I hit enter. All right, and 0, it says, is 1.01. What is that? Again, what is it? It's a time. So how long is a hat in the air? Pretty much 1 second. All right. Now let's answer a question that you could pose for yourself in the real world. If you had a basketball and you were going to throw it up in the gym, okay, you're standing on the floor of the gym. Okay, about how high would the ball be? If you're going to launch it your hardest, how high would you say the ball would be in meters off the ground when you're about to launch? About 1 meter off the ground. Okay, so make yourself an equation for this now. You can go to your y equals and just start typing it right away. Now tell me this. I know you don't know, but what's your gut feeling on how many meters you could throw that ball per second, and as in 1/1000? How far do you think that ball could be from you? Remember, it's meters is like 3 feet, okay? So they're like yards. How far do you think you could throw a ball in 1 second? Any clue? 1/1000. How far could you get the ball away from you? 10 yards? 10 meters? 15 meters? 5 meters? Write down what you think. I'm curious what you think is going to be normal on this. Just write it down, and I'll get your feedback in a second. So I'm trying to figure it out is what's a realistic velocity? Because if we know that, we can figure out how high a person can throw a basketball. All right, how many of you went with a number that is less than 10? How many want the number bigger than 10? All right, so the less than 10s win. So I'm going to go with, but there were some people that said bigger than 10. How many said about 10? How many said like 5-ish? All right, I'm going to go with 10 then. I'm going to stick with 10. It's a nice number. All right, so assume for a moment you could throw it at 10 meters per second. What is the highest you could throw the basketball then? One of the things I like about this is it's kind of got lots of good real-world stuff in it. Hopefully you're using 10x plus 1 as your equation here. Okay, it's going off my screen now. What do I do? What button fixes that? Zoom 6 might do it. Let me try that. Zoom 6. It might still be... Oh, that worked. Cool. Okay. So hopefully you found second, calculate the maximum. Let's go with Mr. HM in the back corner. What'd you get for the max? 6.1 meters. Raise your hand if you had the same thing. Okay. So that means 6 times 3 is it's about 18, maybe 20 feet. All right. That's like 2 basketball hoops high. All right. So now that you know that, gut feeling, do you think you can throw the ball higher than that? Think you can throw it more than 2 basketballs high? Probably depends on the kid. Would you agree some people in here probably couldn't even throw it that high? There's other people in here who might be able to throw it higher. So it's a reasonable number. Okay. So then, what is the longest you can keep the ball in the air? Again, if you're stronger, you can throw it higher. It's going to be in the air a little longer, but thank you. Do you need to pass through you? No, straight you're in here. Good. All right. So all I'm asking is, how long was that ball in the air? This surprises people because they think they could throw the ball up and have it be up there for like 5 seconds or something. No way. No way you could keep the ball up in the air for 5 seconds. Yes, sir. Okay, good. That'd be good. What did you get for an answer? And by the way, what did you do though? Did you do there's a lot of things on this menu. Did you do maximum? Did you do 0? Did you do intersect? Which one did you do? The 0. Okay, I agree. So I'm going to 0, and then I'm going to go, there's 2 zeros. I'm picking this one. Enter, enter, and the last one's right on it. Enter. Did you get? All right, you were right, 2.13. And what the heck is this little number trying to say to you? -1 E12? Think about it. What is that supposed to be at that spot? What is y supposed to be? Y is supposed to be 0. Okay, that's your calculator's way of saying, I'm getting really, really close to 0. But it's not giving you exactly 0. Now, some of your calculators will have a 0 right there. Who's actually got 0? That's about half the class. Okay. And the others, rest of us, your calculator probably got something like this, which is really, really close to 0 if you think about it. If the decimals move 12 spots to the left, 0.000000000000001 is something like that, is your pretty close to 0 number. Okay, good enough. Now, last kind of question. Let's say that the ceiling in the gym, so this is a small gym, like let's say it's like a church gym or something kind of a smallish gym, so you're throwing the ball up with the same equation, but the ceiling is at 14 feet. 14 meters, sorry, 14 meters. So when would the ball hit the ceiling? If you don't know what to do, ask the kid next to you. I'm going to pause for a second while you noodle that one. The ceiling is at 14 meters. Okay, so we've got an answer. What's your answer? When does it hit it?
Never.
Doesn't ever hit it. Prove it. How can you prove that? Unnamed person I'm pointing at. So I don't have to say your name on the video. You could calculate the maximum. That's very good. And the maximum in this case was what again? 6.1 meters. Okay, so they would not possibly hit it. Another way you could prove it. You could put in something on your graph. What could you put in? What do you think? Exactly. If I put in a second equation of y equals 14, it's going to draw a line up here, and it's going to be clear that you aren't touching that line, right? All right, but let's say that the height in the church gym is actually 5 meters. Would you figure out for me when the ball would hit the ceiling if it's at 5 meters? So basically what I did is I gave you a height. You can't do second calculate value. If I give you a height, you got to do the same thing that one of our students just pointed out a minute ago. You put in an equation for that. Hopefully, you went to the y equals screen. And then you went to the y sub 2. And then you typed in 5 meters. And then you graphed it again. And then you saw that it goes through. Now this is important. Do you get that in the real world it would not hit the ceiling twice? You have to get that. Because otherwise, if you by accident find this answer right here, you are wrong. Because it never would get there. It would have hit the ceiling already over there, and thus that spot would never happen. So you better find the right, what is that, a 0? No. Is that a maximum? No, it's an intersect. Good. So I go, second, calculate, intersect is number 5. And then I'm going to go to first curve. I really hate how they do this system. But first curve means, am I on the first line? Yes. Now it jumps to the other line. Am I on the second line? Yes. And the third question is really guess. That means get really close and then hit enter. And yes, it works to just get really close to the spot you care about and hit enter, enter, enter. But that's what it's doing. It's doing that so that if you have 5 lines, you can see where just 2 of them cross. You can pick this line and that line and see where they cross. All right. Did you get 0.54 seconds? Raise your hand if you did. All right, good. Then you have the right answer for when the ball hit the ceiling. And what's that 5 over here? That's the height of the ceiling. Okay. That's pretty much everything you have to know. All right. So your test tomorrow is going to encompass all kinds of questions like that. Remember my advice about a picture's worth 1,000 words. If they get trickier, like they say, okay, the man is standing on top of a llama, which is standing on top of the car, which is actually a Chevy, which is parked by the levee, but the levee is dry. Anyway, you got to like draw this and figure out, okay, where is the person when they start launching the rocket into space or whatever. And you'll know what their y-intercept is by drawing a little picture. Okay, that's all the advice I have for you on this topic. In general, this is asking about the window. We talked about how you could zoom in or zoom out to get a better window. And we've done problems like that already. So I think that's all I need to do. Have a good day.